give a few seconds for people to get here before I start. Got to deploy the snacks. It's very important to deploy the snacks and have them in a ready position prior to streaming. Wow, you got node cloning working that fast? It's only been like 3 hours. That's pretty good. I think Daniel Ben-Mervi should be busy on other things and should not have time to watch me in my splendid shirt programming, but who knows? He knows better than I. My AST nodes have a lot of pointers in them at this point, so it's not really practical to memcopy right now. At some point I should do a pass and see if I can try and memcopy more. Yeah, I don't know. We'll see. It's sort of the thing where to do the better version of that, I kind of want to wait till I can rewrite the compiler in my own language, because that would be much easier to do. The language is designed to do that kind of thing better. So I'm inclined not to work too hard on it in C++, but we'll see. Yeah, to stream from the switch, you need an external capture device, which I do not have. And therefore, it's not going to happen unless I decide to aim my webcam at the TV and like re-angle the TV and this. I might do that. It depends if I'm, I might be in danger of yanking a cable or something, but I think, this monitor turns a lot. So if I just turn the monitor enough and turn the TV enough, it might work. We'll see. Yep. All right. Okay. When last we left off, I was intending to go start doing a revamp of the polymorphism and ran into another bug. And let me check where the camera is. Make sure, oh, that's okay. As long as I sit up straight. But I'm probably going to slouch a little, so let's aim it. Oh, you can't, yeah. Anyway. I ran into another bug that had nothing to do with polymorphism. We fixed that, so now we're going to go and clean it up. And the first step in cleaning it up, as I was talking about before, is to get rid of this kind of situation. So what I want to do now is make it a compiler error to say this, to have a polymorphic thing internal to the body of a struct, or sorry, the body of a procedure, so that you have to do it with a parameter. And I'll make that an error, and then I'll fix this demo to still run. And then at that point, I should be in a position to do a cleanup, because like I said before, at that point, then we will know after parsing the header of the procedure whether it's polymorphic or not, and that helps tremendously. And I can get rid of some stupid hacks and stuff. And then that's not the only thing that I'll clean up. There's like 3 or 4 things to clean up with polymorphism, but that's one of the main ones. Hello, Maxwell Perlman. I don't understand the handmade hero question. We're doing, so far, not too advanced lighting in the Sokoban game, but it's, HDR back buffer with non-trivial shaders. It's about, about a third as complex as what's going on in the witness. Like, we don't do light probe rendering or anything in there yet, but we may. Okay, so now how am I going to do that? How do I detect this? So now, I believe when I see an identifier with a $ in front, I flag it in parser.cpp. Oops, in parser.cpp. My monitor is crooked, it's going to bug me. And I flag it as ident is, let's look at the ident flags. Ident, this can be overload. No, it's not that. Is it a declaration flag? Well, let's just look at parse expression helper. If there's a $, we parse a type instantiation. Okay, that's a different case. Where are we here? That's still type instantiation. Okay, so there's, interesting. So we can't actually put an identifier anywhere with a dollar sign, which is good. We don't really want to. So if I put one here, like, I believe that won't even parse. Let's try it. Unable to parse a statement. Yeah, so what's going on is that we only look for this in the context of a type declaration anyway. So that's good. It's been like a long time since I've looked at this code. So now, what is the other dollar sign? There's like 4 places where we look for dollar sign. Okay, that's the name version. So that's fine. This is different. This is completely different from what we're looking for. So this is for when you want to substitute a value, which only already can happen in the parameter list. So we're not worried about that. Here can be lambda equals true. Okay, this is just, we're looking ahead. We're looking ahead by a symbol. Because our lambda parsing just starts with open paren and then some argument declarations, we do some look ahead to see if it would be a lambda or just another sub-expression in parentheses. So that is what that one is for. This is a comma-separated expression list. So we need to do this, but it's less important. So I'm going to write on my list, fix me in parser.cpp. So this is a case that we also need to take care of, but it's a very rare case. Although, okay, that's weird. Maybe I should hit this one first, actually. So procedure call arguments, we parse a separated expression list, which means that we actually would parse this, f of, so yeah, well, wait, where's my, oh no, I deleted that. So I'm not sure. So it's parsing a separated expression list. And its for type instantiation is false in this case because it's a regular procedure call. And the dollar sign checking is only if its for type instantiation is true. The only time we would call it, let's look at when we call parse procedure call arguments. So here it's false. No, call arguments. Call arguments. So here it's false. This is just regular expression parsing of a procedure, which is what we just hit with that example I typed. And this is the only other case. And I believe this is a struct. Where are we? We're already parsing a type instantiation. So it's like we parse a struct name and then some arguments after the struct name. So the problem is we're allowing a dollar sign in the following thing. I have to thing is a struct and int. Why is my thing off? All right, a and float. Whatever. We're just making a dumb thing. So let me just make sure that okay, so that parses and runs. Now if I say thing is a thing of 5. That should work. But I believe I parse the following. Yeah. And it's getting till way later in the pipeline, right? It's saying, oh, polymorphic variable foobar is needed but was not specified. So this is one of the cases. I actually should handle this now. This is one of the cases when I was letting you just have a random one of these pop up later in the procedure. And we don't want to do that anymore. We want to simplify this by requiring you to declare that in the argument list and not have these sneaky hidden arguments. So, I believe yeah, so let me read this comment. Yeah, I'll leave that till later. Okay, so I believe we just changed this to false, honestly, because for type instantiation that's the only time that variable is used. And it's only used to control whether we parse polymorphic variables. So I'm going to change the name of this from for type instantiation to allow polymorph variables. I'm going to do that in the header file as well. And then let's make sure the compiler still builds. Look at all those wonderful warnings. Oh, they're so pretty. Well, if you make a bad hack, which I do often with the intention of coming back and cleaning it up later, which is fine as long as you really do come clean it up later, then if you actually put a comment there, especially with some tag on the comment that you're able to search for later, then you can realistically find those bad hacks and clean them up. Whereas if you don't comment it, as many people do not, then it's just lost in the code forever. And your code gradually decreases in quality. So the fact that I put those comments in there is actually a sign of code quality, believe it or not. Okay, we still compiled. And we still do the same thing. So now we disallow this. And I believe that we disallow it simply by changing this to false, which then means those are the only 2 calls to that routine. So we can get rid of that argument. And I think it doesn't make sense to have it there. Well, this is not the most friendly error message right now, but I think that's fine. So now here we accepted that variable foobar as a polymorph variable of the procedure, and we didn't get an error until way later, like down at this bake. And this is not even that helpful because it doesn't tell you where foobar is and all that. So now we've actually rejected it in the parse phase, so that's good. That is good. So let's get rid of that. Call arguments. Right, so we never allow polymorph variables. In separated expression list, we still need to have that because that we will call with true, I think. Let's see, let's do it one at a time. baby steps. Like I said, I've been away from programming for like 12 days, and my brain has been in a completely other dimension of reality. So we'll take it baby steps. Which, if my damn program compiled faster, Visual Studio, baby steps would be much more fun. Okay, so great. Great. So let's look at separated expression list. False. That's the only call? Really? Really? Okay, let's get rid of that. Hey, look. So my entire incomplete fix me, this is a horrible hack thing goes away. Yeah, indeed it does. Although it's interesting whether we're going to lose enough expressivity. I think this will still work because there's another path for that to parse. We'll see. See what happens. Anyway, this whole thing goes away. So, boom, bada boom. Boom, bada boom, bada boom. Oh, C++. C++. Okay. So, all right. Did we break Sokoban? We broke Sokoban by doing that. Okay. That's a no good. That's a no good. Okay. But so let me show you the source code there. Oops. Sokoban. So basically, we're saying there's some table of some key type and some value type. And, right. I have to undo things that I just did. I have to undo things that I just did. But that's okay. So I need to put those arguments back. But I need to set it to true only contextually when well, I mean, I can do some hack to know whether I am parsing a type declaration that's in a procedure argument or something. However, the thing that I've just thought of that changes everything, is look, in this language, we allow people to submit syntax trees, at runtime. And you can't submit a new procedure yet. You can only modify old procedures, but it's in the game plan that you can eventually submit a new procedure, right? Just like any other syntax tree. And if you have an identifier somewhere and it's flagged in this way, then, you know, like what I'm saying is only checking for this at parse time is not a good idea anyway, because when you submit a syntax tree, you're bypassing the parse time things, and we have to, or we should. Oh, I should have. That was weird. All right. You got to do this sometimes. All right. I think I ended up deleting all the references to $ in the entire file, which should have told me something. Okay, so we're back to this version, and Sokoban builds and runs. So when I parse something, let's change that variable name, because that is good no matter where we end up. So make sure that still works, because we're, oops, not that. Not that. I've got so many commands in my back buffer. That one. Okay, baby steps. Now, when I say oh, it's, no, I didn't. It's single quotes, not double quotes. Okay, that's for must implement. Okay, so what happens is when we see the $, we flag something as inst defines polymorph variable. And so the problem is, you know, if somebody can submit an arbitrary syntax tree that is flagged that way somewhere internal, and we don't catch it, we're going to do something really bad or undefined, right? And we'd rather catch that error anyway. So my inclination is actually to let it parse and ignore all this stuff at parse time, and catch it at type checking time. Okay, so if I'm type checking a type instantiation, such as, first of all, is anyone confused about what's going on? I'm sure people are, because I've barely got a grip on it because it's been so long. So if I have a type instantiation like this, yeah, we're basically saying it's okay if it's in the header of a procedure, it's not okay if it's down here. And the reason it's okay if it's in a header is because, we want to do type matching. What file were we looking at? Table. You know, we want to be able to do this. And these are really type matching on the header of this procedure, and they like get promoted up, etc. And we're going to clean up the way that they get promoted up. So basically, if I see something in the body like this, that's no good. But if it's in the argument or return scope, it's good. Now, fortunately, I can just look at the current scope that we're evaluating in, and just those are tagged as to what type of scope they are. So there's imperative scope, right? And then there's this stuff. So if we're parsing a type instantiation, we had better be in an arguments block or a return block if it's tagged as defining a polymorph variable. Otherwise, no. Say again exactly what we're fixing, cleaning. Basically, I'm doing many steps to simplify the implementation of polymorphism because it's still too complicated. It's been getting gradually simpler ever since the initial implementation, but it's still a little complicated and a little scary. And so one of the things I'm getting rid of is this ability to introduce random new polymorph variables that you can bake explicitly, right, in the middle of a thing. We're making it so that they all have to enter in via arguments or return values, which didn't make sense back when I did this demo initially, but it makes sense now. So we're getting rid of this, and then because we get rid of this, then the compiler knows what the polymorph variables are for sure with 100% confidence without having parsed anything after this brace, which greatly simplifies some things, I think. Yeah. It really greatly simplifies some things. And it may be actually a couple of day project to go through and work it all out, all the simplifications. But that'll be exciting because it'll make the code much more fun for me to work with in the future. Ginger Bill just tweeted a link. Yep. So he's got a new entity that takes a polymorphic thing. Yep. Given that you're catching a dollar sign in the context of an expression, why can this not be checked at parse time? It can, but like I said, that won't really solve the problem because somebody might submit a syntax tree that they constructed themselves that didn't come from the parser, right? Or maybe they took a few things that came from the parser and then swapped around some subtrees. And we don't want to take this C or C++ policy of like having a ton of things that result in undefined, although that may be unavoidable to some degree when it comes to syntax tree manipulation, because syntax trees are so complicated that specifying every corner case might be hard. But I want to, when it is possible to clearly say what's legal and not legal and have that enforced by the compiler, then I want to do that. So if you have something flagged as declaring a polymorph variable and it's in the body of a procedure, that is just illegal. And if we only catch it in the parser, it won't catch the error when people start doing sophisticated runtime code generation. No, so $sign only is supposed to declare a new variable, right? So if you use some type internally, you would not have a $sign. So yeah, the idea is that all the things with dollars go in the header. That's what we're trying to do. So if I go into typer, inst defines polymorph variable. Is that really the only time? Okay. So yeah, this is our big, when we're type checking a type instantiation, which is, an identifier plus arguments or whatever of a type, this is the big block of code we go to. And before we check whether we resolve, because we might resolve to undeclared, right? But up here, I'm going to say disallow polymorph variables if they are internal to a procedure scope or if they are in a data. Okay, well, if they are not in an argument or return scope. Oh, do I not know the current? That'd be bad. Oh, I don't know the current block of the type instantiation. But I can add that when I flatten. Or maybe I do. Let me look. So this is a type instantiation. It's quite a big structure. So I don't think I have a thing called enclosing scope. I don't. So let's put one there. Someday I might unify knowing how enclosing scope is. But anyway, assert enclosing scope is not null. And then if auto scope equals the enclosing scope, if scope block type is not equal to, yeah, so we have block arguments and block returns. It's not equal to arguments, and it's not equal to returns. Report error int attempt to define a new polymorph variable using $, but this is only legal in declarations of procedure, arguments, or return values. That seems like a mouthful. But we've got enough problems. Let's not worry about how to phrase that better. So then, when we flatten the instantiation, well, there's this convention that we set enclosing scopes when we flatten. So, God, type instantiations are pretty bulky right now. All right. In theory, I should build this in debug because my assert won't go off if we're in release, but let's just see what happens if we run in release. Let's see what happens. Hopefully Visual Studio doesn't get confused by the fact that I changed the size of a struct in a header file. Really? It didn't catch it. All right. Well, let's figure out why it didn't catch it. So this is at line 557. Conditions, inst line number is equal to 557. No? Really? Maybe we returned earlier. Boy, I sure wish I could just drag that breakpoint upward like I could in previous versions of Visual Studio a long time ago. Is it really 557? 55 claims it's 557. Really? What am I not seeing? How are we not hitting that? Well, let's try this. Let's pop in on that error message, and then we can see what the serial number of it is, and or directly look at data structures. Change the line number of the breakpoint in the conditions window. Yeah, but that's annoying, and I don't know. It was better when you could just drag it. Okay. So, where are we? We're in infer types for an expression. Right. No, this is far. This is not going to give us the information. Wait, what? Why do we have a lambda here? Are we polymorphing a lambda? Oh, we're polymorphing internal. Right, duh. That's correct. That's no surprise. So we're polymorphing internal. It says, hey buddy, you did not supply this. Okay, what I think happened is oh, duh, okay. Here's what's going on. I am not smart sometimes. I mean, it's fine because I haven't looked at this code. So here's what's happening is, you know, I just put this thing in type inference, right? But as I said in the previous stream, type inference doesn't happen on this stuff until you successfully instantiate this procedure. To successfully instantiate the procedure, the compiler needs to say, oh, you supplied all the variables, let me put those in the slots, all right? This error is happening because we're not successfully instantiating the procedure because, hey, there's a variable you needed, and it wasn't specified. So the issue is that you know, we also, there are several steps to this thing that I'm trying to do. And one of them, I was thinking, oh, after we disallow this syntax, then we'll change the way that we're adding it to the types block of the lambda, you know, because that was one of the simplifications that I wanted to do as part of the bounty of this. But I have to do it now before that anyway, because if I add this foobar to the types block of this lambda, I will never be able to instantiate it anyway. So what I need to do is only add things to the types block if they're in the arguments or returns. And I don't remember even how add to types block happens. Is it in here? I don't even remember if there's a thing called add to types block. Yes. Okay, so okay, that's quick lambda. That's a special case. What is this? What am I even looking at right now? General. Okay, if we see a dollar sign, no, if we saw a dollar sign and we flagged something as polymorphic, then we add it to the types block. Okay, so here's what needs to happen, actually, is I need to check for this in both places. It's a little bit inconvenient. I need to check for this. Duplicate check happens in parser.cp. I need to actually check for it in both places, depending on whether this comes in through parsing or the AST addition. So we'll do that. Duplicate check happens in parser.cpp colon all right, and then so we're switching again to a strategy of only allowing them in the header in the parser, but in a different way than we were doing it before. It is now only legal to have these in the type block. Actually, do this. Scope. Attempt to define a new polymorph variable using dollars only legal blah blah blah, and we return null here. Let's see what happens. What the hell? We're just going to run release build. That's how we do it. So long to compile. Okay, good. And it caught both of them, but Sokoban still compiles. That is a committable offense. Parser catches. Now, of course, I haven't robustly tested the syntax tree submission version of this, but I think that's going to have to be tested via fuzzing later on, and it's like a whole different topic. So I'm going to stay focused on what I'm doing right now, and I'm not going to test that other version that I added, which is not a good thing to do if you're shipping things, but I'm not shipping this yet. So let's make sure that I can run Sokoban. Yeah, so we didn't break anything. So parser disallows internally introduced polymorph variables. That is good. So let's make the demo compile now by changing these things. Why is my indentation messed up? Internal. I mean, I'm using a totally I'm using a totally hacked thing that someone sent me like 2 years ago. I don't know. Whatever. Well, that was legal when I did this demo, but not anymore. So instead, we pass it as a parameter and don't bake. So this was originally demoed as a cool way to use bake. This is no longer a good demo of a cool way to use bake, because we don't use bake, but that's fine because it makes our language simpler. Simpler version now. God, okay. It's being really stubborn. Internal, x u16, some type. Oh, I can get rid of this because that was just a parse test. I can get rid of that. And it's just this. Y some type equals x. So now it is in the argument scope. Oh, it's being stubborn because I really am only 2 characters in. I like 4. Why am I doing that? I don't know. Whoops. That was not a good commit. That was not what I wanted to run at all. Here we go. Okay, so this builds now. Any questions about what I just did? Any questions about that? I'm going to get another drink while I wait for questions to come in. Did I change $, to just $? Yes, that is the new syntax for that. So the idea is, if it's $1 on the left, you're baking a value, right? And if it's $1 on the right, you're baking a type. It's much more straightforward. Actually, let's do that next. I'm going to change. So there's still the $$ version. That's like the optional, you can bake or not. And I think I'm going to change that to $? Like, am I baking this? Let's not do that yet. We'll do that if I rat hole and get confused. I need to do something for morale's sake. Yeah, it's pretty hot in Seattle right now. Super hot. So this plus Sokoban right now are my full-time project for the most part. I mean, I spend time working on other things a little bit. So for example, I'm going to be doing some Witness iOS stuff very soon. I might even stream a little bit of that tomorrow or something. That might be a fun way to get into it. But for the most part, most of my time for the past more than a year has been going into the compiler plus the new game in this language. Yeah, we'll rewrite the compiler in the new language someday, but not anytime too soon, because it's not a good, it's not a very leveraged way for me to spend my effort right now. I have not played said Nintendo game yet. We actually, for the witness, yeah, we had one investor that lent us the money to finish the game, which was very good, because if I had to ship it on the money we had, it would have been, we could have done that, but it would have been a much less good game. So basically, the money from Braid paid for about the first half of Witness development by money-wise, which is way more than the first half by time, because we started with a smaller team and ramped up. So the money from Braid paid for the Witness probably from 2009 to the beginning of 2014, I'm going to say. And then all of 2014 and 2015 were paid for by the invested money. And then we came out at the beginning of 2016. Wow, was it that long ago? Oh my God. Because there's very little difference between procedure declarations and procedure types. They'll be very ambiguous to read and check. But the main problem with this is that this syntax for foreign procedures does not extend to other declarations like foreign variables if you want consistency. Yeah, I don't have foreign variables right now, so I might change the way that those are tagged, but that's a relatively small thing. I haven't really needed foreign variables yet. The equivalent of extern variables in C. Although I did, so I'll show you one really ugly, stupid hack to get around the fact that I didn't. Where is it? Is it at the bottom here? Oh, maybe I removed it. I think I removed it. I don't even remember exactly what it was, but I think it was for allocation stuff that I demoed last time. I had something that I essentially needed to be an external pointer because it was a pointer that lives in the support library, and I didn't have a way to declare that. So I pretended it was a procedure pointer, taking void and returning void, and then I casted that. But yeah, it's not a general solution for external data, which we're probably going to want when we interface more heavily with C and C++. So yes, that part of the syntax will probably need to change. I don't understand what you're saying about the syntax for a lambda type being very different or being too much the same from the syntax for a lambda, because I don't see that as being a problem. It's like a lambda with a body has a body, and a lambda that's not doesn't. And you have 1 colon or 2 colons. It's like, I don't know, it seems straightforward to me, but maybe I don't see the problem. Can varargs be baked now? I don't think so. Although maybe. Like, I haven't done a super thorough job on constant data, like I've been procrastinating a little bit on, what do you call it, just syntax for constant aggregate data structures like arrays and structs and arrays of things, right? So I have this hacky thing in there that I demoed a long time ago, right, as the first step, where you declare the type with a colon in the array, but it doesn't handle all the cases. For example, you can't just have a constant struct outside an array or anything. And the reason I've been procrastinating on that was just because I hadn't made up my mind about certain philosophical issues. But I believe I have made up my mind on those issues now, and so I can just do the simplest thing that works now. But I feel like that's lower priority than doing the polymorphism stuff, which is why I'm working on that. Is there a name for this color theme? No, it's just some colors that I typed into my .emacs. A virtual laser pointer that you could use as the person spectating. Yeah, but I mean, SharePlay, I don't know. It's easy to support SharePlay if it's just the really straightforward thing of streaming. It's a lot more work if you're adding a lot of special features like that. And the thing is, we're such a small team that if we started doing features like that on every platform, we would be, I mean, we're still working on the Witness a year and a half after release. So we just can't do stuff like that. Does it support that syntax? Not really. It approximately does, and that's what I was talking about, but it doesn't do it for all cases. And what I decided is that the C version is actually fine. I early on had philosophical objections to that syntax because, like, you don't know the type of the thing on the right until you know what the thing is on the left. And early on in the days of the compiler, it was not clear if it was good to introduce something where the flow of type information went in the opposite direction of how it usually goes, and whether that would confuse the programmer too. But now I think it's probably fine. We'll see. We'll see. Do I plan to move the team to Seattle? I don't think so. I mean, people want to live in San Francisco. Could I name any besides the sausage one? If you go on Steam, whoops, I have a thing called My Curation Group, and how do I get to the list? Curator. So I have my list of games that I recommend. This one is not out yet, but it comes out pretty soon, like in a few weeks. And then you can just go, and I don't know if all these are ambitious in the way you're talking about, but some of them. So Inside is ambitious in a certain production value way. Glittervitten Grove is ambitious in a certain way. I don't know, I mean, most of these aren't that ambitious, I guess, but they're all good games. So if you want to play some good games, go to My Curation Group. My Curation Group. Curation Group. Okay, let me get back to programming. So, in the parser, there's all this add to types block. Now the rule is going to be, once we're done with parsing, everything is guaranteed to be in the types block in a specific order. And that is known by the time we're done parsing arguments. So what I'm going to try to do now, there's a thing called stealing polymorphism that I am going to take a look at now. Is it in Typer? Do I not have, wait, what? Did I rename it? Okay, put arguments into lambda. Okay. So basically, if you're a procedure and you take another procedure as an argument, and that procedure has polymorphic variables in it, then they're really your polymorphic variables and not really that procedure's polymorphic variables. Or at least that's the way that makes sense to me. So I have this thing called polymorphism stealing, and maybe I already simplified it in the last pass, but let me look at the implementations of some of these things. So if we set arg lambda, then we clear polymorphism off the arg lambda, and we take it for ourselves, and we reset it, which may seem cruel. So let me switch to Emacs, where I'm more comfortable. Wait, why is this file modified? Was this never saved? All right. So let's look at clear polymorph flags. Where does that live? In polymorph.cpp. Yeah, so I have to do this whole recursive cleaning. Yeah, this is some of the code that I'm hoping I can delete, but maybe I can't, actually. Okay. Clear, so I call clear polymorph flags on the lambda type of the arg. Right. Okay, so the difference is, now in order to be correct, I don't need to clear any polymorph flags on anything in the body of the lambda, right? Just in the arguments and returns. And maybe I wasn't doing that before. So it might just be that I don't get to clean up the code, but the compiler is more correct. We no longer allow sneaky polymorph variables in a lambda's block, so we do not need to do this. So this is a pretty major change. So I'm just going to compile and make sure Soakbon runs and the demo runs. We're going to take baby steps. When we work with polymorphism especially, man, baby steps are a good idea because it's so easy to break something. All right. So that's good. So we removed one line of code. Okay. Right, so these don't any longer exist. And let's look at this. We should figure out if this is wrong at this point. So recursively, so clear polymorph flags on an inst. So we say, okay, this inst is not polymorphic. I don't know if we really need to do this. I guess we should not. I think, or no, I think we should actually, sorry. So, okay. go back to here where we're calling this. So we're just calling clear polymorph flags on the type, which is just this. Okay, that's actually not recursive at all, which I guess is good. I guess the recursive part comes in when we're copying the lambda in order to instantiate it with new types, right? So this one, this being a sort of a leaf procedure, I'm inclined to move it to here and inline it if that compiles. You never know what's not going to compile in C++ without you fervently reordering everything. All right. So great. There's a very minor change, but like I said, we're doing baby steps today. So so at parse time, when we steal polymorphism, so we're looking at the argument or return value. Well, I guess the argument here. Right, you can't steal from a return value because there's no type inference on return values. So, yeah. So we only need to check arguments. So if it's an expression, then it can be a lambda. This is like if it's lexically written, the whole lambda is lexically written there, right? Otherwise, it's a type. So let's get rid of that old comment. So then if we have an arg lambda, well, I guess we're asserting, because it's either we set arg lambda here, and decal expression is true, or we set it here. So we're going to assert arg lambda is not equal to null, and we're going to get rid of that. We clear the polymorph flags on the lambda type, which is not correct. This has to be recursive, annoyingly, but we might have a better way later to make it recursive. So incomplete. This is not correct if we have nested polymorphic struct declarations since clear polymorph flags does not recurse. Example of what will break this is ft is table of $a, table of $b, $c, right? So that, you're going to get a type instantiation for this, and that's going to have another type instantiation nested, and well, no, this is not, sorry. This is a struct instantiation. So I want f, g is a procedure from $a, comma, procedure, we'll call this b, I thought I have a test for this. So my theory right now is that this doesn't work, but I thought I had a test case for this in that demo. So let's see. We'll make a test case in the demo. You know, whatever. So here we have a type instantiation for G, and oh, no, this will work because yeah, this will work. Well, I'm not convinced that this is incomplete. It'll work because the inner one will get stolen by the next one, and that one will get stolen by the outer one. So I remember working on that way back originally. Review, I am not sure whether it is sufficient to non-recursively clear flags here, but we'll test it later via fuzzing. Okay. So the recursively clean flags, let's see when that happens. It gets called a lot from polymorph.cpp. So I have a feeling we'll just naturally be cleaning that up on its own. But I'm a little bit satisfied by this though so far, just because, I mean, I didn't really do anything yet, but I have this understanding that at parse time, at parse time there used to be a recursive flag operation, and there isn't anymore. Now it's non-recursive, except in the implicit recursion of, or in the implicit iteration of what happens, like I said, when an inner guy gets stolen by a next outer guy, which gets stolen by a next outer guy. But that's fine. That's pretty clean. So what I'm going to want to do is when I start simplifying the polymorph code, just keep an eye on this stuff and make sure that it works. So that's working, and that's working. Wait, is Twitch working? Is it all good? Okay, I guess so. People are asking about fuzzing, which I guess means that they can see what I'm saying. Let me at least review the recursively clean flags. Lambda. One thing that I could do okay. I can actually clean some of this right now. So like I said, you're no longer allowed to add sneaky variables in declarations, which means that, whoops. So the statements, members is where variable declarations go, and then statements is like where the imperative statements and subblocks go. And it should no longer be necessary to clean that kind of thing because you can't. So that's good. That makes me happy because we're at least cutting down how much recursion is happening. And then the only blocks that this should be called on, as far as I know, are the argument and returns block right there. And so this violates the don't repeat yourself principle a little bit, but I don't really believe in that. Well, sorry. Where was that from? That was from there. Oh wait, what? What am I doing? Sorry, yeah. So let's just check in, like I said, baby steps. So that worked. Okay. So we don't need polymorph clean statements. And now, instead of doing, this is like a trivial procedure. And so whenever that happens, I would say, I'll just do this. Right. It's just goofy to do that. So we have one less overload of that procedure. I should have done a line of code count this morning, so I would know how much we're removing. It's always less than you think, but it's still nice to see the number go down sometimes. All right, so demo, that works. Boom, that works. Okay, great, great. Does my for macro use C++11 range-based for? Yes. But that's one reason why I don't like it, because range-based for in C++ actually kind of sucks in a few ways. So I actually don't use that for macro as much as I thought I would when I made it. All right. Now, so the only entry point on recursively clean flags is this one thing. And actually, this looks like it's redundant with that, right? Wait. Recursively clean flags. When we pass a lambda, we recursively clean flags on the lambda type. Oh, except for that if beforehand. Yeah. I see why we do this. Yeah. So recursively clean flags, the arguments block and the returns block members. So each of these members is a declaration. So in these loops that I just flattened up into here, each of those calls this one. Yeah. It's so, if I had an easy way to iterate over two loops and do the same thing, I'm thinking about this as a language feature in my language. I'm hoping that it's actually easy to do with a high level thing. I really just want to say for everything in these two groups of guys, do the same body, because then the only reason this is a separate function is because it's called from two places. If it was just one thing here, then I could just paste it in there and that would be great. Oh, well. Oh, well. And have, I guess that's it. So those are the only overloads. So that got a little bit cleaner. I still would rather not do it. I still would rather have copy clear the flags at some point. Except maybe it is cleaner to set a variable on the copy to clear the flags as it copies, and we clear that variable after copying the arguments, but before the returns. This may eliminate a significant amount of complexity and thus be worthwhile for something that feels like a hack. That may be a better way to do it. I'm thinking right now, maybe I should do that or try it out. So basically, when we copy the lambda, well, it's an involved operation for a few reasons. Maybe I should be looking at simplifying this. Okay. So we copy the types block, which is where all the polymorph variables live, right? And then if there's expressions already bound to anything in the types block, because you might have a lambda that's partially, some of its polymorph variables are defined, but not all of them, for example, if you use bake or something, right? So, you know, we need to do that. And handle various other things. And then we need to make sure that we got everything. If we didn't, we complain. Or if it's a silent check, then we're not really trying to instantiate this. We're seeing if it's an overload that we want to call or whatever, right? That's why this silent check thing is here. So when testing overloads, we might run through and do all this work. Yeah, there's a lot of things I want to simplify. So I want to start with, before I mess with the copier, I'm going to put down copier clears polyflags so we don't need recursive underscore star or recursively underscore star. Did I have a note here to, yeah, okay, I did that, so. I could always make what a lambda so it doesn't mentally pollute. Oh, the 4? It's not that it's a lambda or not. It's just that sometimes, you know, like sometimes I want to know the index of what I'm iterating, and it's just, I don't know. you can make all that happen in C++, but it's annoying. I mean, it ends up not being any better than the old version that I used before, range-based 4. So I would just, in all new code, I would fall back to the thing that we used in the witness, which is pre-C++ 11. Okay, so what I want to do now is I want to start looking at this kind of code that fills in the types block with values. And I want to make sure that that understands that types blocks are always in a known predefined order and stuff. And then I want to look at value bakes a little bit. There's like this way that value bakes are considered to be different from type bakes, and they're really not now. They're the same under the hood. So I should be able to get rid of that complexity. So let's look here for a minute. Find matching polymorph. So for every polymorph instance of this function, if the arguments blocks match, then we return the matching one, otherwise we don't. So that's fine. Wait, what is it called? Struct arguments blocks match. Oh, that's the argument version, or the struct version. And the procedure version is basically exactly the same, except it calls types blocks match. So let's look at types blocks match, because that's the one we actually care about. This is old wait, what? Okay. Okay. So here I want to enable this assert. Let's go, before I enable this assert, let's go make sure that we don't, that no asserts fire in debug mode. We'll try this. We're going to run the debug compiler. Okay, that works. I'm going to run the debug compiler on Sokoban. That works. Okay, that's good, because that could easily have gone badly. All right. So I'm going to put this assert here. And if this is not true, I will have to figure out why it's not true and fix it. Because the theory is that types blocks are all of any given procedure, polymorphic procedure, are supposed to always be the same size, like the same number of entries. And those entries are always supposed to be in the same order with the same names in matching slots. That should never differ. That was untrue when I went and implemented bake and did stuff, but now bake should only be filling in slots on things, or filling in values on things that are already in the right slot in the types block, right? And that's going to be what enables us to be simpler. So let's try it on the demo first. That didn't assert. Try it on Sokoban. Didn't assert. Okay, that's good enough for me. So assert DA identifier name is equal to DB identifier name. So this asserts that there's the same number of entries, and this asserts that they're named the same thing. So let's make sure that that happens. Wow, that actually compiled a little bit fast. Visual Studio, good job. Claims it succeeded. Okay, Sokoban compiled without asserting. Demo compiled without asserting. Okay, this is good. This is good. So this all goes away. So now what is unbound? I believe I may have changed this a bit. Where is that? Is unbound. Types parser.h. That's a weird place for it. If it's got a type inst, and a type inst is types block entry for polymorph type variable. Makes sense. But nobody in parser uses that. So I'm going to move it out of parser, and I'm going to put that in ast. Going to put that in ast. Oh, the recursively clean flags overload. Yeah, I mean, it's just if I make it a lambda, I don't know what the performance implications of that are. I don't trust it in C++, so I'm just not going to go there. I don't ever go to lambdas unless I need the functionality of a lambda. And anyway, it would still be a procedure, and I'd really like to just not make it a procedure. So, yeah, okay. Is unbound types block binding has been moved. SVN commit and simplifying assertions. We have simplified some things. Again, I'm not going to do that now, but like I'm not sure about this exactly. If it's got a type inst, is types block entry for polymorph type variable? You know, I feel like the type variable part is a misnomer now. I believe that's used for values as well. So maybe we should make that less confusing. Oh my God, look how many times this is used. Let me look at value baked. Let me search. Whoops. Let me search for this again. God, Visual Studio, I hate you sometimes. Hate you. Where do I assign this? Okay, very few places. Two. One is when I. Where is this? What are we doing here? This is just inferring, okay. So that's fine, that's propagating it forward onto something that's not a type instantiation. So this is the only place it gets set, unless I set it with a weird syntax somewhere, but I don't tend to do that. So this is in add to types block. So as far as I know, that gets used for values as well. Okay, this is when we're doing the polymorphism. We just looked at that. This is, right, when we get the thing. When we okay, so this is when we have an instantiation that's polymorphic, right? And then this one well, they both seem to be for that case. This is kind of weird. Maybe I should clean this up. So maybe for value bakes, I don't add them. Okay, that's the next step. So for value bakes, I probably do not add them to the types block yet. And I should. Oh boy. No, I should. Okay. Yes. There's a slight complication with optional bakes. That, right, I remembered that during the meditation retreat, and then I forgot it again. So I'm going to change the name of that variable. What was it called? I'm going to change the name, even though currently, whoops. Currently, it's only for type variables, or it's only used that way. I'm unifying value bakes with type bakes, and this will be simpler. So we will take out the type part of it, and that has no functional effect on our program, but you know, we're making the variable name slightly shorter, and we're going to be less confusing once we unify it. Okay. I'm sure this is all just random babbling to people watching the stream, but half of what's happening is I'm being reacquainted with this code that I haven't seen in a long time and remembering how it works and stuff. Okay. Next step is going to be that value bakes get added to the types block at compile time. Oh, you know what? I'm going to revert that commit that I just did. Or did I commit it? No, I didn't commit it. Because actually, I think I did that in the wrong order. Like if I simplify them down, because there's a lot of uses of that variable, some of them may really depend on it being a type. So let me just see. I hope I didn't change anything but these. It looks like I didn't. I don't know. Random sampling. Oh. Well. Is that the only change in polymorph? No. Damn it. Whatever. We'll lose that. I'll notice later that it's pretty old. Down here. More of that. Okay, I'm just going to revert all this. Sometimes programming is just about reverting. So what I'm going to do is the opposite. And then unify later. Because the problem that I was foreseeing is the following. Remember that I had that check when you try to polymorph that all the polymorph variables are satisfied, right? Otherwise it's an error. If I go and add value bakes, especially potential value bakes that aren't baked, to the types block, and you can't tell the difference between those and types entries, then that error will fire erroneously in cases when it should not. So we don't want to do that. So I'm just going to do this. I'm going to say, well, maybe it's a type block entry for polymorph value bake variable. Add to types block. Bool is for value bake. Bool is for value bake equals false. Okay, so if is for value bake, we're going to say one thing, otherwise the other thing, and this is maybe not the best way to do it, but it's how we're going to do it, and we're going to see what happens. Okay. So in parser.cpp, we call add to types block for arguments. Okay, wait. I'm looking for a flag. I don't remember what the flag's called. Okay, declaration auto value bake, right? And here we want to say add to types block interp lambda decal identifier true, because it's for a value bake. It's for a value bake. Now the reason to do this, so remember a minute ago when I did all this assertion that, the procedure, or the order of the declarations in the types block has to be the same for every polymorph instance, right? Well, we have to ensure that somehow. And if we're just doing arbitrary polymorphs incrementally, we might not do things in the same order, right? Like we might bake some parameters first and then other parameters later, and so on. And so if instead of randomly adding stuff to the types block when we do a value bake or whatever, if those slots are already there after parse time, or are required to be there, you know, if you submit the syntax tree in code, then it's a lot simpler. Like I have to think about fewer things. And it'll simplify the polymorph code, I think. We'll see. I don't know. This might be the wrong thing to do. But this is what I do sometimes. I explore and I see if it's the right thing to do. Why is Steam, God, I hate Steam. Why is it popping up crap to distract me? There's no way to turn that off. Well, there's ways to turn that off, but I guess it is not stored on your account because I've turned it off on some computers. The thing that there's no way to turn it off is when you start up Steam and it bombards you for 20 minutes with notifications of everybody who has to be your friend in the past year. So I just gave up on it and I don't try to turn anything off. All right. I mean, I don't hate Steam because we sell our games on it. So that part of Steam is great, but some things about the Steam client leave a lot to be desired. So much to be desired. Okay, so we added to types block. So now I think that this will break everything. Well, it doesn't even compile now, so let's see why. Oh, there's no lambda, right. What is lambda anyway? We don't frickin' know. So do we have a lambda stack? I think. No. So first of all, we can get lambda. We might not be properly checking some things here, but let's. Yeah. So I'm going to say get the current block that we're parsing. If block type is not equal to block arguments, report error, decal internal compiler error. I am pretty sure we should not get here if we are not any arguments block of a procedure. Return. Okay, so auto lambda is block belongs to lambda. Assert lambda. Assert lambda. That's the name of my new band. Assert lambda. Okay. Unhandled type and translate type. Yeah, so like I said, we like frickin' broke everything. Let me, because this is a little more than a baby step that we just did, I'm gonna go back and remove that add to types block for the new thing for a second, just to make sure that with this new internal compiler error check that it never fires. So, okay, that works, and that works. So now we're back to where we were, but we're adding this thing to the types block. So now we don't want to add something to the types block when we polymorph, but I'm not sure that that is the next thing to attack. Maybe the next thing to attack is what is going on. Okay, so Sokoban, oh wait, rebuild. It's confusing to do that sometimes because you lose, okay. So Sokoban generates a bunch of errors, but also, okay, we get redeclarations here. So that's good. The redeclarations are because we're still adding to the types block when we instantiate the polymorph for the value bake, which we'll be able to take out now. What about the demo? Okay, so the demo does a bunch too. So this is all fine. Yeah, and this is all like in the standard library or something. I'll work on it one thing at a time. So let me take out this part, the redundant. Instead of adding an item to the types block, we just want to find it. We want to find it, which we already have to find it, I guess. I don't know. Okay. So I think we only just comment out this line, and it won't solve all our problems. Well, no. No, 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 no. No, 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 no. Okay, we're doing something kind of dirty here anyway. So it's good that this is a little bit of an error-prone thing. So we had a declaration in the argument list of some lambda, and it's got the $sign on it saying bake this value, and we're pulling it out of the argument list and putting it in the types block, and to do that we're twiddling some flags, and the thing that makes this volatile is like, you know, say some flags get introduced later that need to be there on arguments, or if there's some other state that's not a flag that needs to be some way in a declaration in arguments block but not in a types block, like this could be a latent error waiting to happen. So this was always a kind of a dirty thing. And so we're going to do this the other way. We're going to say find in types block a corresponding declaration. I guess I don't have that function anymore. What's it called? No. I just have find in block. Yeah. There we go. Whoops. So instead of pooping all over the argument declaration and then transplanting it and hoping it works, now we already have a slot waiting in the types block, and we just post it in the appropriate way. Right, so this is gone. So we remove it from the arguments, but we then say find in block decal identifier name and lambda types block, and if no other error, I'm not sure if people can ever get to this, but whatever, decal attempt, well, let's call it internal compiler error for now, attempt to bake something that is not present in the types block. How did this happen? I don't know. How did it happen? Okay, so and now we still need to do something kind of error prone, which is we need to reverse a little bit what happens here, but that's less scary. So we're going to just kill the type inst other type inst equals null, and other expression equals this thing and we might as well Okay, so like I said, this will not solve all our problems, but provided that this compiles, yes. It should get rid of these redeclarations down here. Then we're still going to have all these warning unhandled types, and I will have to investigate that. Oh, well, crash. So that's interesting. Oh, right. So we have when I add things to the types block before, do I assign them? Because this time I assigned things to, or I made empty declarations, which means their expression pointer is null. I might have had the expression pointer be a thing called type def poly use, which is just, it's just a non-null value that I could set things to in these cases. No, wait, what? Oh. Okay, if both expressions, actually, no, here's what needs to happen. So remember when I put that field with the really long name on the type inst, because that was how I was going to differentiate between the type variable and the value variable for now. Well, folks, this is the place that I need to differentiate. I guess. Let's see, it depends why we want to know. So the thing is, when I put the value in there, remember I cleared out the type inst by setting it to null, which is then going to destroy the differentiation. Maybe I just shouldn't do that, because I'm setting the inferred type. Probably shouldn't do it. But that still doesn't solve all our problems. I just blanked. Like I said, I haven't been programming for a long time, and I've been off in a separate mode of mind for 12 days, so now concentrating once in a while, I lose it. We'll see if I'm all better by tomorrow. What did I even just say? I just totally spaced for a second. I was saying that we're trying to differentiate, and it depends on why we want to know if the types blocks match. So first of all, okay, that's static, so I'm pretty sure that nobody else can call it. Yeah, so that's good. So this is only for the purposes of finding a matching polymorph. So we want to, okay, so I'm making a note to remove that weird type instantiation field if we don't need it. Because we may not need it, because what we're going to do is types blocks match. I'm going to, now that there's other things in the types block besides type arguments, okay, I'm not going to change the name for now, but I'm going to have to make this not be called the types block eventually. It's going to be called like the bake block or something. Because calling it the types block is just confusing. Okay, so in this routine, we are only trying to check oh, interesting. I'm sorry to be getting caught up on so many abstract issues. So right now, when I polymorph a function, it's a two-step process. I actually polymorph it twice, and I'm not sure that that's a good idea. Probably isn't. But it was one of the things I wanted to clean up. So the first step is the one that always happens if there are type arguments, is you match all the type arguments, right? Then the second thing is if there's value bakes, we then match all the value bakes. And that, again, that's historical, the reason why I do that. So if I ever change that to one step, then we can have a case where okay. We don't want to differentiate here. I'm going to just go for the gold. We want to say, look, if this thing matches exactly all the things, then it's fine. So if there's two expressions and they're both null, which is a thing that couldn't happen before because this was only called for the results of polymorphs, then it's just, there's two variables that are both unbaked. These are both unbaked value bake arguments. And I'm going to assert that that is the case. So what was it called? From value bake. Yes. So I'm going to assert both of these things. That's fine. Let's see if that goes off. Nope. Oh, but we didn't fix our crash. Why didn't we fix our crash? Wait, what? Did I edit the wrong? Dude! So sometimes Visual Studio and Emacs fight and it just deletes what I type for some reason. And I think that just happened. Didn't I just type a whole thing in here? God damn it. This is like programming is hard enough. I just wrote something here, but I don't remember what it is. Right, didn't I just, was that somewhere else? No, yeah, it just deleted it. It just deleted what I typed. All right. Did anybody see, did I make a mistake somewhere where like I reverted that? I don't, maybe I'm just tired and I need to go play a video game. But I'm pretty sure it just frickin' up and destroyed my change. So what was I doing? I was asserting, assert, declaration flags, and God, this, programming is difficult already. I just wish things like this didn't make it worse. Okay. These are both unbaked value baked arguments, so they match. If they are mandatory bakes, we'll catch that later. Pretty sure Visual Studio kept the old version open. I thought I was doing that in Visual Studio, though. Maybe I was doing it in Emacs. I don't know. But Visual Studio is supposed to be detecting changes and telling me. So if I saved it from Emacs, I don't remember now which I was doing, but if I saved it from Emacs and I had modifications in Visual Studio, it's supposed to say, dude, so let's pop up a dialog and say, dude, I don't know what to do here, and not just like delete my stuff. Assholes. All right. Really? Okay. Let's see what it is. I really dislike that bong so much. Okay, so DA identifier name, DA line number, it's a T. In basic, is that a quick lambda? 1645. No, it's just a thing. But it is. Oh, right. Comes from value bake is not, that flag probably isn't necessary anymore. It's the wrong flag. We want to search for, so comes from value bake was a thing that I was setting later. Well, 256. It doesn't have any value bake related flags set. That is, as we say in the business, problematic. It is problematic. this case is exactly what I'm looking at right now, by the way. What if it's a value bake of a type constant? Well, that comment is really old. So I'm going to get rid of that, because that doesn't make sense anymore. Visual Studio silently deletes all kind of stuff, by the way. It'll delete stuff like if you're just typing in the middle of your text, it'll delete identifiers in some cases as part of its stupid, smart syntax thing. Everybody on that team is so fired. Yeah, we'll talk about the new function in the next demo, by the way. And I'm banning this guy. Yeah, just don't assert. You'll never have problems with things asserting. Ban, where's my, no, don't mod user. It's so bad that the mod user and the ban user are right next to each other. Okay. So, like if you accidentally mod someone who's being obnoxious via a misclick and you don't realize for 30 seconds, they can do an incalculable amount of damage to your chat room. Okay. So it's good that I asserted there. I mean, it's actually, in this case, removing the assert probably fixes the problem. But, I mean, I want to make sure that these are marked clearly, if only for future reference. Like it may be that right now there doesn't happen to be a way for this case to arise, except in the case of two value bakes that are unfulfilled yet, but it is bad mojo to fill your code with subtle assumptions like that. Maybe I'll just make a new thing called, I'm just going to make a new thing. I think there, actually no. So the reason why I was setting comes from value bake down here is just that that declaration didn't exist. Excuse me. So the thing is, actually, like we said, we're not putting the declaration in the types block. We're not transplanting it anymore, right? We're starting with the declaration in the types block, which means that we can set the declaration ourselves, or the flag ourselves. Right, add to types block. Remember when we did this? Okay, wait. Okay, we want to do it here. So when we make a new declaration to go in the types block, if it's for a value bake, we set comes from value bake way back there. So we have this information. Hate that noise, much earlier. Okay. Really? What? What? Crazy. Comes from value. Did it delete that? Okay. Maybe the is for value bake is not being correctly called in that case. Let's see. Let's see. And why, wait. Why are we not catching it up here? You know, I want to know why this flag isn't set, but in reality, we should maybe be catching this in this clause instead. But let me just look at. So it's that same T still. Still got the same declaration flags. So let's look at that again. I mean, that's a value bake. Oh. Here's what's going on. I think. My theory is, so because we used to be setting that flag in type inference, which happens after a copy. But we moved it to parsing, which happens before a copy. And we may not need this flag later anyway. But there's this thing called declaration flags to copy, which when we copy a declaration, so comes from value bake is not in there. So if we made a copy of that thing, it'll copy the types block, but that flag will be cleared when we copy. It's so good to be able to think of things like that without having to trace through the code for a long time. Hey, look. It compiled. And it ran. I don't know why it ran when there's all those unhandled type errors. Attempt to bake something that is not present in the types block. How did this happen? Oh, snap. Yeah, dude, everything I did may just be wrong. I may have to revert this whole thing. This may have just been a learning experience because I forgot. Let's go to this part of the demo, and I will show you the horrible thing that I forgot, which I should have remembered because I talked about it today. You can bake arguments that are not declared as value bakes at any time, right? So I can just make a new version of multiplier and substitute in B. And this will not be in the types block because it didn't know that it should be in the types block, because why would it be? So I need to think about this. This may be the pausing point in the stream now, because I need to think about whether this whole thing that I just did is correct. Like, I want to figure out I want that to be an invariant that things in the types block. I think I want it to be an invariant that things in the types block are always there. or in the same order. I want the comparison of those types blocks to be simple, maybe, or at least that's what I thought I wanted. And so then, maybe I have to lexically sort things that you bake rather than them being there a priori, in which case I can revert everything I just did, because that's not important. But I need to think about that a little bit to come to a conclusion there. And really, the thing that I would really like to get to, anyway, is the thing I was talking about before about making value bakes less separate. And I had thought that the way to make them less separate was to put them always in the types block. But if that's not possible, put them always in the types block a priori. If that is not possible, which it isn't, then maybe that's not an important component of the coming simplification. Maybe I should look at instead doing it from the other direction and performing the entire polymorph at once. Or maybe I should just sort of look randomly through the code and look for other simplifications to do. Because I feel like if I go, the reason I didn't want to go from that direction originally, from top down, is that it feels complicated. Like, it's just like, oh, let's just break a bunch of stuff and wedge value bakes in there. But that may be the right way to do it. I am going to take a recess, I think, and think about this and maybe play some video games. Probably not streaming, or maybe I'll entertainingly try to stream in my new console. But before I take that break, does anyone have any questions about what I just did and all these things that happened or didn't happen, as the case may be? I mean, most of, everything up to the last check-in, which is probably scrolled off the top, but everything up to the last check-in is good, which is mostly some relatively minor cleanups and preparations. I did remove a little bit of the recursively clean polymorph stuff. That was good. Not very much, but every step is good when you're dealing with a system this complicated. So I think that next time I stream on this topic, which may be later tonight after gaming, I'm going to re-attack the problem from the top-down direction and try to do value bakes in the same pass, which may be messy, man. That may just involve breaking the code real bad for a while. But again, I think it needs to be done. And if I can't do it so incrementally, then maybe that has to happen. But I'm going to be thinking about maybe what's a way to do it incrementally that doesn't involve this thing that I was just talking about, this types block equality. Yeah, I know this was kind of hard to follow. I'm sure, this is a relatively esoteric subject. Like, everything that I'm doing right now is very particular to the specific details of how I chose to implement things. And, different implementations, it's not that they wouldn't also have problems, it's that they have different problems, right? And so I'm just working through what's the best way to do it, given my chosen implementation, and or just deal with code that is a little bit historic and that I'm trying to find the best way to clean up. So I think, I don't necessarily expect people to understand very clearly what the hell is going on, but I wanted to stream this because why not? I haven't streamed in a while. And sometimes it's good to see just like, okay, this is what programming is sometimes, is trying to understand and clarify this thing that you already did that already works, but that you'd like to be simpler than it is. But it's a little bit abstract and a little bit complicated, and just whittling away at it piece by piece. So we did, complexity of code is super linear in N, where N is the number of little complications in it. And I did remove some of the complications so far. They're not complications at the core, they're like complications around the edges. So that made the problem a little bit more tractable. But more progress needs to be done in that direction, or in the top-down direction. So we'll see how it goes. How am I using fuzzing for testing my compiler? We're not yet. It's just that's the future plan. When I say the types block, are you talking about a block on each procedure header or a global block? If the former, does it mean that you're considering a parameters block that includes both types and values? Okay, the way it works right now is that every Lambda has, well, it has its body scope, right, obviously, which may have subscopes. And then there are 3 scopes wedged outside between the Lambda and the outer scope, right? And it's, so you have the body, and then you have the return declarations, and the argument declarations, and then the types block. And those are chained in an inheritance relation. So, and the reason why it's separate scopes is so that, you know, things from the inner scopes can override my name, things from the outer scopes, if they need to. Which may not totally make sense anymore because, I don't know, maybe it should be illegal, for example, for something in the types block to collide with something in the other blocks, but even then it still makes sense maybe for them to be separate. Anyway, so when you're looking up a variable in the body, you just look in the body scope, and then the returns, actually not even the return scope, you skip that one because you don't use return, you only look up stuff in the return scope in a return statement, right? So you skip the return scope and you go to arguments scope, and then types scope, and then out. And type scope is a misnomer now because if you have values that are baked in, they also go in the so-called type scope. And it's just called type scope because type bakes came first before value bakes. So that renaming is probably going to happen as well. How do I intend on using fuzzing testing your compiler? Random generation based on some spec of things. Basically, yeah, you just sort of randomly generate. I think the best way to do it, because you don't want to just randomly feed strings into your compiler, or you do a little bit, because that's one type of testing. But what you really want to do to really test out the parsing and the type checking and stuff is like you train a Markov model on a program like Sokoban, which is 50,000 lines. Then you just have that Markov model generate some text, right? Possibly inserting it into the middle of other procedures and whatever. And so it looks like valid code, which keeps you away. Like if you just generate random text, almost all of it is going to be monkeys banging on a typewriter, and it won't be testing anything very interesting usually. But if you generate stuff that looks like valid code, then you maybe get far enough to test type checking and things like that. So that'll probably be a major element in fuzzing, but that is far enough in the future that we're not thinking about that. Did I see some of the things people do with Mario Maker? No, I have not paid attention to that. All right, I'll maybe pick this up later tonight. In the meantime, maybe I will do a game stream. I don't know. We'll see. Thanks for coming by. It's break time. Break time. I mean, these days, it might not be a Markov. I mean, it might just be a neural network because people do neural networks now to generate text, and that works okay. So maybe it would be a neural network. I don't know. Something. What's the difference between A float and $A float when you can bake everything anyway? The difference is that $A float gets baked without the caller having to think about it. So it gets baked on call if A is known always. Whereas the other way, you would manually bake it yourself, which is, you know, it's basically comes down to whether the writer of the procedure wants to talk about the baking or whether the caller of the procedure wants to talk about the baking. You read Exhalation based on your recommendation. It was great. Do you have any others? If you haven't read Ted Chiang's entire short story book, Stories of Your Life and Others, you should read that. That's great. That is great. All right, everybody. Thanks for coming by. We may resume before too long. See ya.